We are going to consider this part of our equivalent, which is actually the approximate equivalent values. That is another part which is very, very important in our syllabus as we are dealing with our transformers. We are going to see that depending with the circuit that you are actually given, I'm just gonna have a smaller presentation having the primary side and the secondary side, on referring on the secondary side. Let's say this is our primary, and we've got V1, I1, X1, R1, and there we're going to have the impedance affecting what? I1, that is the part of X1 and R1. Because of this part here, X1 and R1, we're going to have impedance. So referring, because we are talking of the referred to the primary, talking of the primary side. Okay, talking of the primary side. We are going to have this resistance R1. Then on the other side, we are going to have R2 bar like this. And this will be X2 bar like that. Meaning to say these are referred to the primary side. Okay, we are talking of R2 that we had on the secondary referred to the primary side. Referred to the primary side, the reactance. So this is the same thing that we have when it is now considered about the secondary, meaning to say that will be referred to the secondary. It will be your R1, okay, referred to the secondary. Then we also going to talk of what X1 referred to the secondary. That is how we're going to actually be denoting these ones, the resistance and our reactances. So there's nothing, guys, that you are going to actually have. We need the equivalent values. So our equivalent values, they are going to be denoted by the letter E for equivalent values. Equivalent, we are going to use the letter E. So let's talk about the first part. We have got the equivalent resistance referred to the primary side, which is our RE1, referred to the primary side. So that is going to be R1 plus R2 bar, which is this one. Remember, referred to the primary side, we're going to be talking of what? R2 by. As I said, on the secondary side, let me just write the current is going to be I1 by. Then the reactance, we're going to have X1 bar like that. Talking of the impedance, all these guys talk of the impedance, which is our Z is going to be Z1 bar. Talk of the resistance, R1, that is the part of the secondary, the side referred to secondary. You just oppose primary. Okay, referred to primary, you just oppose to secondary. So that is the condition. That is the condition. So that equivalent is going to be R1 plus that resistance referred to the primary, which is R2, like that, and which can be calculated from R2 into, this is our transformer ratio, this one. As you are referring to the primary, N1 over N2 is representing our transformer ratio, but it's gonna, so it can be represented in other textbook. They can write this as K squared, where K is the transformer ratio. On this other side, it will be 1 over K. Okay, so it depends with the textbook that you are using. So that N1 over N2, like I said, is representing our transformer ratio. So this is our transformer ratio, meaning to say, if you understand this, it means you can use anything in place of N1 over N2. You can use the voltage V1 over V2. You can use the current I2 over I1, depending with what you are given there. But as it is referred on the secondary side, if you check, it's going to be R1 there into N2 over N1. This is the opposite you're opposing. So if it is N2, you're going to change V2 over V1, I1 over, you have to interchange for you to have N2 over N1 as referred to the secondary side. So then N on top, N1 referred to, okay, we're talking of the primary, so it's N1 on top, secondary, N2 on what? On top. So this is what you're going to have. Even if you talk of the equivalent reactance referred to the primary, as we are talking of the primary, it's going to be X1 plus X2 bar. which is given from x2. That x2 that is given there is the same x2 that you write here, x2 into what? N1 over N2 bar, which is the same. If it is R2 bar, there we're going to have R2. So using guys, it's just a repetition. Just to repeat, it's just what is it that you're calculating. So we have got the equivalent reactance of the primary, then here the equivalent reactance where we are considering the secondary side. So I'm going to talk about this, guys, as you are doing our calculations. And as we do understand that from the resistance in our normal calculation, where there is a resistance and a reactance, we can calculate the impedance. Okay, so Z is equal to what? That is the square root of R squared plus X squared. So our X now is going to depend. That is the part of the equivalent impedance. Okay, so you consider ZE1, it is going to be from RE1 and XE1, which can be written in complex notation, which is in the J notation as RE1 plus JXE1. The Z2, on the other hand, you are dealing with the secondary side, so you're going to work with those that are on the secondary side. Also, it can be written in J notation, which you can convert to, which you can also convert to polar form. This is rectangular, so it can be converted to polar form. Remember your calculator, how to convert in polar form, which is fine. We're going to talk about that. Then, like I was saying, guys, the RE1, RE2, these are equivalent resistances. We're talking of the resistances there. XE1, XE2, these ones are equivalent reactances. The E there, equivalent, but just primary, equivalent, secondary. The equivalent impedance of primary, equivalent of what? Of secondary. These are the ones that you have been calculating. So the question is not going to be directly asking you to calculate R1, RE1 and XE1. No, they can just ask you to calculate the equivalent impedance straight. So for you to have that equivalent impedance, is it of the primary side? Is it of the secondary side? We are going to consider that you have to calculate first their equivalent resistances and also the equivalent reactance of that part. You must consider in order for you to have what? The equivalent impedance. Just like what you have when you're calculating impedance, you need what? Resistance and what? Reactance. So for it to be equivalent, it must have equivalent resistance and it also must have equivalent reactance. That is the condition. It must be the same. And not forgetting, like I said, anything about our transformer ratio can be used in place of N1 over N2, meaning to say the vice versa. When it is written N2 over N1, you're interchanging N2 over N1. You interchange this, so it's going to be V2 over V1. You interchange this, so it can be given as I1 over I2, depending with the condition that you are having, guys. It's just one and the same thing. So this is what we have. Refer to the primary side. This is what you are going to, refer to the secondary side. We are going to have these values of R1, RX1, Z1 with this bar. When it is referred to the primary, you consider the secondary. This is what we had. These are the ones that I was writing here, guys, if you still remember, on top here. So you must consider it is just like an opposite. Primary, you use 2, okay? When it is primary, you use 2. Referred to the secondary, you use 1. That is the condition, guys. If you just understand that, you are good to answer any question. Then from there, we are going to be talking of the percentage or the per unit values that are important as we talk of the percentage impedance. Remember, the impedance on its own, it is being taken from the resistance plus Jx. Okay, we are considering plus Jx. But when you consider, say, it is now a percentage, it means this is supposed to be a percentage for this resistance also is supposed to be percentage, and the reactance also must be a percentage. So this is the condition for a percentage impedance. When they ask you to calculate a percentage impedance, you must have your resistance as a percentage. You must have your reactance as a percentage as you are given. Then the per unit value is now determined when you divide. Remember, percentage, guys, is you express anything as a percentage, like let's say you've got 2/5. How do you express to a percentage? You multiply by 100%. You get a percentage. So to remove that percentage, the opposite, you must divide by 100% to remove that. So in order for you to have a per unit value, PU, per unit value, whenever you talk of per unit, that is the PU. You can use the PU in short. So in order for you to now to have the per unit impedance, per unit resistance, per unit reactance, you divide these percentages that you are given by 100%. That is, you divide by 100, the values that are given in percentages. So the opposite is true. If you are given per unit value of the impedance per unit, you can convert them back to the percentage by multiplying by 100%. The opposite is true. Just this is mathematics, guys. To percentage, you multiply from percentage. I mean, to going back to the normal term, you divide. But as you are going to that percentage, you must multiply. So the opposite is true, divide. So meaning to say, we can calculate per unit resistance, reactance, and also impedance. From these calculations, having I1 and V1 and the equivalent resistance, we can calculate the per unit resistance. Also on the secondary side, we can calculate the per unit resistance. These are per unit values, per unit reactance from the equivalent reactance, per unit reactance from the equivalent of the secondary side, of the primary side, per unit of what? Of the impedance. Per unit. These are decimal values that you are obtaining. These are decimal values of the percentage of the percentage. When I'm talking about the decimal value of a percentage, meaning to say they have been divided by what? By 100%. As we are seeing, these are remember, per unit value, it is a value that you obtained when you divided this by what? By 100. So it means for you to go back to the percentage now, as a percentage, you simply multiply by 100%. When they now ask you to have it as a percentage, they can ask you to say, calculate the percentage resistance. The percentage resistance is equal to per unit resistance that you calculated, because it's a decimal of the percentage. So you multiply it by 100%. It is now percentage resistance from per unit resistance. Percentage impedance, it means for us to have a percentage impedance, it must be taken from a per unit impedance. We multiply that by 100%. The opposite is true. To obtain per unit impedance, you divide by 100% percentage impedance. So I think, guys, we are now back to our mathematics. That is our mathematics, but converting to and coming back. So we are going to see calculations where these are to be applied, and the voltage drop, meaning to say we can make it the subject from what we had here. We're just making the subject. This is the voltage drop. So you can make it the subject. We simply have to cross multiply. So with these are this is where our formulas are. This one is just, we can say, we can make this, we can make change of subject and have them as voltage drops now. Due to resistance and reactance, we write them as voltage drop. But guys, what is important is that, can we calculate per unit resistance, impedance? Is it possible? If it is possible, then we can calculate their percentages. With this, you can calculate any question that you are given. With this understanding, you can calculate any question. So I want us to consider from what we had, which is the part of our equivalent values, up to the per unit values, which can be given as percentages in answering typical questions. We are given a typical question that the primary and secondary resistances of a single phase We're dealing with a single phase 2000 as to 400 volts. This is the voltage distribution, primary, secondary. That is the indication that we are having there, primary and secondary. So meaning to say we have got V1 according to the data that we are given. That is V1, 2000 volts. V2 is also given as 400 volts. That's a single phase transformer R. They are saying the resistances of this transformer are respectively the resistances, primary and secondary, primary, secondary resistances. So meaning to say we have got the resistance of the primary side, resistance, that's R1, resistance, primary side. So the first one, 0.8 ohm and 0.05 respectively, meaning say the secondary one, gonna consider as R2, which is 0.05 ohms. And let's move on. The corresponding leakage reactances corresponding to what we had in the primary secondary way, the reactances now, the leakage reactances are respectively. So meaning to say we've got X1 of the primary, which is 6 ohm, and also X2 of the secondary, which is 0.2. These are not equivalent. No, they are just resistance reactances. They are not equivalent. There's nothing about equivalent there. They just said the primary resistance, not equivalent resistance. So it's R1, R2. There's nothing about the E. The E is used when they say equivalent. Okay? If the transformer draws a current off, to draw, that is to take in from the supply. So meaning to say we are given the current in to be 28.5 amps at the primary side. With this whole information, the question is calculate or determine the equivalent impedance referred to the primary side. The equivalent impedance referred to the primary side. Which impedance are we talking about? That's ZE1. Remember, referred to the primary side, equivalent impedance, we are talking of the ZE1. But this ZE1, in order for us to determine this, we saw that we have got two formulas there, can be written as a normal value from the equivalent that we had, remember, from the resultant there, the square root of RE. We're talking of the primary, so we're going to talk of RE1 squared plus XE1 squared, equivalent reactance of the primary, which can be written as ZE1 is equal to, in the J notation, so you're going to have this as RE1 plus JXE1 using the J notation, complex numbers. So as we can see, definitely that on these two formulas that we can use, there is no way we need equivalent resistance and also its reactance. That is what we can see. We are forced to calculate this. So meaning to say from our calculations, you must find this. Okay, so we're going to calculate, in this case, first one, RE1 and XE1, which is referred to the primary side. So these calculations, guys, RE1 can be taken from our formula. Just going to substitute in that case. So our RE1, we said this is going to be equal to R1 plus, is referred to the primary side, that is going to be R2 bar, which is equivalent to, that is R1 plus that one. As you can see, there's a bar there. So you take the R2 as it is, then it's going to be K squared, where K is the transformer ratio, N1 over N2, as you refer the primary side, primary over secondary. Okay, that's the formula that we had. Okay, so you can just know our formulas, guys, direct, which is fine, or you can relate back like that. So meaning to say our RE1, the equivalent resistance as referred to the primary, we're going to substitute our R1, everything will be there. So R1, going to substitute, that's 0.8 plus R2, 0.05 into N1 over N2. So like I said, the N1 over N2, this part is limited. As we can see on this part, it is limited. We do not have N1 over N2. But remember, this is a transformer ratio. So N1 over N2 can be written in different ways. This is V1 over V2. This same thing representing N1 over N2. It is V1 over V2. It is I2 over I1 in terms of current. What is it that is complete that we are given? In place of N1 over N2, we have the voltages V1 and V2. So instead, we are going to use V1 over V2. That is what you're going to have, where we've got 2000 over 400 raised to the exponent of 2. So that is going to give us RE1, and that was going to be 2.05 ohms. This is a resistance, so it's measured in ohms. The same thing, we can also calculate our XE equivalent reactance as of the primary side. So the equivalent reactance of the primary side as we so that it can be calculated as we are considering X1 and X2 bar, which is going to be X1 plus that X2 as it is without this, just going to remove that. So this is N1 over N2 squared. Remember, you're talking of the primary side. Guys, if you've forgotten your formulas, remember, so I don't know, you're going to have a better way to understand those formulas, but they're easy, guys, to just understand as they are. I don't think there's a need of a special way, but you can do that. So X1, that is 6. So you're just going to substitute 6 plus X2, that's 0.2 into N1 over N2. Remember, N1 over N2 concept is the same as this part that I indicated before, that the N1 over N2 will be taken as V1 over V2, which is the corresponding. So this is just going to be the same as what we wrote here, 2000 over 400 raised to the power of 2. So that is the condition, and this was going to give us 11 ohms. So this is what we have, which is our equivalent reactance. So we are referring to the primary. So with this, we can just substitute depending whether Z that we're going to have, is it a direct term that we need, or we are going to use it later on for other calculations that need to be in polar form. But in this case, okay, let's consider the first one. So the first one, we can say that resultant is just going to be taken as the square root of RE1, which we calculated. Remember our RE1, that's 2.05 squared plus our XE1 squared, which is 11. We got this one as 11 squared. So that is 11 squared, just like that. So this is how we could have answer this, everything under the square root. We're going to simplify our ZE1 and obtain 11.189 ohms. But this could have been written considering our complex numbers, the J notation. The J notation. So we could have written this as RE plus J, where we have got our RE, guys, is going to be 2.05 plus J XE1, which is our XE is the one that we got as 11. We could have written this way, which is representing our equivalent impedance as referred to the primary side, which is in rectangular form, which also can be written in polar form. So remember, in polar form, this is now you guys and your calculator. You don't need any mathematical presentation, just need your calculator. So remember, on your calculator, you're going to have shift to polar form. Must be to polar form. You're converting to polar form. So shift, you must write polar form there. 2.05. So that's 2.05. Okay, my 2 is not showing here. 2, 0.5. Then you separate this 11. That's going to be shift, close bracket. Then you put 11, close the bracket, is equal to. So as you can see, for the value of R in polar form, we expect to have R angle of theta like that. So that means our R is 11,189. So that's 11,189. Then the angle theta is given. As we move on here, we're going to see our theta 79,443. So that was going to be 79,443 degrees. In what? In ohms. This is written. This can be written in polar form, depending with what you're given. As you can see, this is the same magnitude of what? Impedance. But sometimes the angle is needed because you're going to be also wanting to represent how the angles will be like at the end. So it will be of the format now that you have to consider that you are given at the end. So you must be very, very careful. All right, so this is what we had. Just in any case, maybe we might need this RE1. This is 2,05 ohms. Okay, then our XE, we calculated this, our XE1, this is 11 ohms. Just in case, maybe we might need this anyway in our calculation. And our Z1, guys, as we saw, for two answers that we can consider for that Z1, we can have it in different ways or presentation. So I don't know. It depends. Like I said, it's going to depend with what you're given. As we saw, you can have our Z1, ZE1, the equivalent. This is the equivalent. So you must have an E there. Okay. We saw that it can be 11,189 ohms, or you can present it as 11,189 at an angle of 79. It was 79,443 degrees. Okay, so let's see. Let's continue, guys. B is just a continuation, just like a repetition, because you need to determine the equivalent impedance referred to the secondary side, meaning to say we're just talking of what? ZE2. This was ZE1, then we're going to talk of ZE2. So it's just a repetition of what we had, but this time you are just considering the secondary side. Okay, so this time you're just considering the secondary side. So as we saw, guys, without RE, we cannot determine this. So we need RE2 and we also need XE2. So that is the major part that you must relate. Okay, so let's start with our RE2. Just like what we saw previously, when we calculated RE1, when you're relating to RE1, it is the same thing when you're considering RE2, that is going to be R2 plus what? As referred to the secondary, this will be R1 bar like this, which is substituted with R1. So we saw that it's going to be R1 into, for the secondary side, it will be N2 over N1 squared. Secondary side on top, N2 over N1. Please, still remember this, secondary side. So it will be N2 over N1. Where now you have to change from this idea that you have, if it was N1 over N2, N2 over N1 would be V2 over what? V2 over, you just interchange V2 over V1. So it means in place of this N2 over N1, because you're now considering the secondary side, you substitute this as V2 over V1. That is the major part. It will be V2 over V1, but nothing has changed, just as it was before. So this will be our R2, 0,05 plus R1, which is 0,8 into now this one. It is now taken as V2 over V1. This is what we have. So it will be V2 over V1 this time. 400 over 2,000 to the power of 2. So that's it. Just combine everything. This was going to give us 0,082 ohms. That is our equivalent resistance. We do the same thing with the reactance. So we can also do the same thing with our reactance, XE2. So this is going to be taken as X2 plus that referred to the secondary, which is x1 bar. So this will be x2 plus x1 into secondary on top, n2 over n1 squared. So that's it. Or x2, 0,2 is given, plus x1, which is 6, into this part as it was before here. So it's just 400, it's a repetition, over 2000 to the power of 2 from the voltages that we had. And that was going to give us 0,44 ohms. So that is our XE2. And with this, our equivalent impedance on the secondary, as referred to the secondary side, can be calculated. We can use the first formula from the resultant of RE2 squared and XE2 squared. Okay, remember your Pythagoras theorem concept. So this is going to be the square root of our RE referred secondary is there, 0,082 plus XE, which is 0,44 squared. So this is just a simple simplification, that you can have. But we are supposed to have this in polar form because we're going to have other calculations that will need that angle to be used or to be applied. So there you need to consider the J notation concept, as we saw that in the J notation, it's going to be the resistance plus the inductance. So that is what you're going to have. So meaning, so you just substitute. What is it that is corresponding to our equivalent resistance of the secondary equivalent? 0,082 plus J XE2, which is 0,44. So this is our equivalent impedance as referred to the secondary, and we can write this in polar form, as we do understand, guys, this is our rectangular form. So in polar form, just like what I did, guys, you're going to have shift to polar form. Your answer is going to give you the value of R and the value of theta. So the R that you're going to get there was 0,448. The angle, you were going to get 79,443 degrees. That is the condition. Or impedance can be determined that way. Okay, so that is it, guys, of the secondary side, and we need to move on to another part. Okay, so let me just write these values again. You do not know, guys, we might need this in our calculations next to come. So you just need to have this. Our RE2 was 0,082. Then our XE2 equivalent reactance referred to the secondary was 0,44 ohms, and that Z, okay, the Z, guys, just remember it, guys. I'm gonna also recall you for that. In case that you need this value, I'm just gonna recall so that we can just use our value, so that for the sake of time, we can finish up. On another part, with these values that we have calculated, they need us now to determine or to calculate the percentage resistance of the transtechno. The percentage resistance is the one that they want, the percentage resistance. I talked of the per unit values that they can give us the percentage. From per unit values, if you still remember, from these per unit values of resistance, reactance, the per unit value can be calculated from this formula. So as a percentage, when it is now percentage resistance, it means we are simply multiplying our answer by 100%. So percentage resistance, you are taking per unit, you multiply it by what? By 100. This is what I was explaining here, that per unit resistance, percentage resistance is per unit resistance times 100%. That is the condition. So if you do have, guys, your formulas, guys, it's just direct like that. Okay, so guys, we're gonna take those formulas. So as we saw from our formulas that Okay, so this is, let us just consider as this is part C. The percentage resistance must be taken from per unit resistance times 100%. And what is the value for per unit? What is the formula per unit resistance? That is the voltage drop over V1. So you're going to have I1 resistance of that, which is the equivalent resistance over V1 times what? Times 100%. But the question, is it wrong to use the secondary side? No, we can also use that. And that is to show that we have got the same thing, the same answer. So we can also use that as the percentage resistance from per unit resistance that we are given. So it is going to be taken as I2 on the secondary side. Then you're going to have the equivalent resistance of secondary over V2 times 100%. Still, you must have the same thing. Right, so this is what you're supposed to have, like even on any calculator. But guys, I'm just gonna use one. Okay, let me just use the both for the sake of our understanding, so that we can see that it's one and the same thing. So meaning to say, our percentage resistance, as we are considering the primary side, we're going to use I1, which is all right. The other thing now is that on these two formulas, one is limited, as we can see. The other one is that we have got I1, we are given I1 in that case here. We are given I1. So using the second formula, it means you are now forced to calculate I2. If you are to use this, because you do not have I2, you have to calculate I2. Now to calculate I2, you can use the voltage, the turns ratio. You can use V1 over V2 is equal to what? I2 over I1. Then you calculate your I2. After calculating your I2, it is the one that you substitute here. If you are to use that, you are going to obtain same values, guys. Okay, so I want you to do that. Okay, but for this one, as we can see that I1 is already there, so we can use the first formula where we have got I1 28,5 times RE1. We calculated, remember, our RE1, it was 2,05. Everything over V1, we have got our voltage at the primary side, 2000 times 100% for us to obtain percentage resistance per unit resistance. This one, it's per unit resistance times what? 100%. We now have percentage resistance. So that was the idea there. It's going to be 2,921%. So we have got that as a percentage. So like I said, guys, can you do this one? But first calculate I2. Then from there, you can calculate your percentage resistance. You're going to get the same answers. On B, they want you to determine the percentage reactance of the transformer. Percentage reactance. So again, it is taken from per unit reactance, but it must be multiplied by 100% for it to be a percentage per unit reactance. And per unit reactance can be calculated from any of these two formulas, considering is it the primary side or is it from the secondary side. So you've got our per unit reactance, guys, as we saw. But the secondary side, again, you need I2. So unless you have already calculated that, then you can simply use that. So you can see that the first formula, where you consider the primary side, is easier. We just going to substitute. So our per unit X here was supposed to be taken from I1 XE1 over V1. But for it to be a percentage, you multiply by 100%. So that's it. I1, guys, we have got everything. 28,5 times XE1, where is our XE1 here? That is 11 over what? V1, which is 2,000. So you're going to multiply this to 100%. And that is giving us the percentage reactance from this per unit reactant. Per unit reactant. Remember the relationship to another opposite. To per unit reactance, you divide. To percentage reactance, you multiply by 100%. Opposite of each. So that was going to be 15,675%. So with this, we have got percentage reactance. And they are now asking us to express the impedance in percentage form. The impedance in percentage form. What are they trying to say? Because they know you have got these percentage values, percentage resistance, percentage reactance. Remember that it can connect the two to give us a percentage impedance. Okay, I wrote this, guys, and explained this. I think it was on top here. All right. All right. Where did I write those things, guys? I think okay, no problem. I'm just gonna explain this part. All right. I think I misplaced the page. Or here, if you still remember. So I still remember that I explained. Where am I going now, guys? Just go here. When I explained this part, the per unit value was obtained by dividing. When you are obtaining, percentage is multiplied, but if they are already in percent, because we do not have like where it is per unit resistance, per unit X, we do not have that. If it was there, we're going to first multiply by 100%. You multiply already. We multiplied by 100%. We have percentage resistance. We have percentage reactance. So we are just going to substitute this as it is because they are already under percentages. We calculated this percentage. They're already under percentages. They're already under percentages, right? Is this D or it's E? This is now E. They're already under percentages. So the percentage impedance will be equal to, instead of us having resistance plus JX here, no, we are going to have as percentage now and also percentage. Where we calculated these percentages, it's there. Percentage resistance is there. 2,921 plus J percentage reactance is there. We calculated this as a percentage, not a decimal, as a percentage as it is. So this was going to give us the percentage actually of reactance. That's reactance as a percentage. You can just write it like that, as a percentage. That's it. So under exam condition or in another condition, okay, we are done. There we are done. I'm just explaining that it can happen in another way, that they will give you this. What is it that you can tell from this? It is the resistance as a percentage, the reactance as this one. So a percentage is because you are given as a percentage. You can check how it is given there. So it means that will be percentage resistance and this will be percentage reactance. So from percentage resistance, you obtain per unit resistance by dividing by 100. So it will be 0.02921. Per unit reactance, you divide this, so it will be 0.15675. If now you want to use these values, maybe per unit resistance and per unit reactance to calculate another thing, I'm just saying later on in another question, they can give you as a percentage. You divide. From per unit, going back here to percentage, you multiply this. If you have this per unit resistance, per unit reactance, guys, do not even waste much time. Just multiply 100%. 100%. They are now percentages. You substitute them. You find your percentage impedance. So we shall see more questions to come from Mason African motifs till we meet again.